Welcome to our latest explainer. I'm super excited to guide you through this journey. Today, we're diving straight into the Earth's physical features. We're going to look at how the literal ground beneath our feet dictates everything, from the climate and biodiversity to human culture itself. From the absolute highest peaks down to the vast, flat highlands, we'll see exactly why landforms are, well, literally the foundation of life. To really ground ourselves, let's kick things off with this incredibly beautiful thought from the ancient Atharva Veda, from a hymn known as the Bhumi Sukta. The earth is my mother and I am her child. You know, it really sets this tone of profound reverence for the environments we're about to explore. It's a great reminder that we don't just live on the earth, we are deeply, intimately connected to its changing landscapes. Now look at this. This perfectly shows the three major landforms that shape our world: mountains, plateaus, and plains. You can practically trace the journey of a landscape right here, starting way up at those towering snow-capped mountains, dropping down to a raised, flat plateau, and then finally spreading out into the low-lying plains. You see that river? Carving its way down through all these elevations? It's like a giant living puzzle that took millions of years to take shape. Section 1. Majesty of the mountains, defining the peaks. Let's just dive right into our first and highest major landform. Okay, so to truly understand these giants, we have to define a couple of vital concepts first: altitude and precipitation. Altitude is simply how high an object is above sea level. Precipitation? That's just water falling from the atmosphere to the ground. In lower areas, that's usually liquid rain. But as we crank up the altitude and move higher up a mountain, the temperature drops dramatically. And if it gets cold enough, that liquid rain transforms into a solid state. Bam! You get a beautiful blanket of snow, which is exactly why these peaks are so often permanently snow-capped. And here's where it gets really cool, because when you're looking at mountains, you are literally looking at geological time. Take young mountains, like the mighty Himalayas. I mean, sure, they're millions of years old, but geologically speaking, they're practically toddlers. They've got these incredibly tall, sharp peaks, and because of tectonic uplift, they are actually still growing. Now contrast that with old mountains, like the Aravalli Range. They're much shorter, and they've been worn down, smoothed out by millions and millions of years of relentless erosion. Now, we usually think about mountains in isolation, right? But when you line up the world's major peaks right next to each other, the differences in altitude are just staggering. Seeing their relative heights stacked up like this across the globe gives us a really fantastic impression of their awe-inspiring scale. And that staggering scale is probably most obvious when we look at the absolute giants of the Himalayan range. On one side, we have Mount Everest, the tallest of them all, straddling Tibet and Nepal, and right nearby is Mount Kanchenjunga, sitting between Nepal and the Indian state of Sikkim. These peaks soar so incredibly high into the atmosphere that they exist in this permanent state of deep freeze. No way around it. It is just freezing up there.
But hey, mountains aren't just an Asian phenomenon. We see wild geological diversity all over the planet. Take Mount Aconcagua, the absolute highest peak in South America's vast Andes range. And then contrast that with Eastern Africa's magnificent Mount Kilimanjaro. What's super fascinating about Kilimanjaro is that unlike the Himalayas or the Andes, it's a completely isolated mountain. It just stands there, all alone, not part of any extended range whatsoever.
Check this out. Comparing the icy slopes of Western Europe's Mont Blanc right next to the lush, vibrant greenery of South India's Mount Anamudi, it really highlights just how radically different the terrain and climate of these landforms can be. Depending entirely on their geographic location, two massive peaks can support completely different environments.
Section 2. Life at high altitudes. Ecosystems in the clouds. Let's shift gears and see how this massive physical scale builds into the biological ecosystems that actually survive up there. Because let's be honest, the extreme environment literally forces nature's hand. On the lower slopes, you'll find montane forests packed with conifer trees, your pines, your firs, your deodars. They grow tall and cone-shaped with these thin, pointy leaves to easily shed all that heavy snow. But as you climb higher into that thin, freezing air, those trees just completely disappear. Instead, they give way to some incredibly tough ground cover. We're talking hardy grasses, cushion-like moss, and lichen that just cling directly to the bare rock for survival.
And hiding right within those deep forests, caves, and high-altitude grasslands is a surprisingly huge variety of wildlife. You've got the elusive snow leopard, the incredibly sturdy yak, Canadian lynx, the soaring golden eagle, the list goes on. Every single one of these creatures has perfectly adapted to navigating that almost vertical terrain and surviving in the bitter cold. Which brings us to Section 3, Living in the Mountains, Human Survival and Challenges. We know how the moss and the yaks do it, but what about us? How do humans navigate and build lives in a terrain that's mostly rugged, nearly vertical, and freezing? Well, since regular farming is pretty much impossible on steep, rocky slopes, mountain communities use this brilliant, ingenious method called terrace farming. They literally cut flat steps right into the side of the mountain. This creates level ground to grow crops, sure, but more importantly, it stops all that precious topsoil from just washing right down the mountain every time it rains. Human ingenuity, right? It never ceases to amaze. But we can't ignore that these breathtaking landscapes mask some very real, frankly, terrifying dangers. The folks who live up there face sudden, violent natural hazards all the time. Avalanches, where tons of snow and ice just give way without warning. Landslides that can quite literally pull the earth right out from under you. And these sudden, violent rainstorms called cloudbursts that instantly trigger devastating flash floods down the mountain valleys. It is a very precarious way to live.
Yet despite all those extreme hazards, human determination is just absolutely astounding. I mean, look at the history made on Mount Everest alone. Bachendri Pal bravely became the first Indian woman to reach its summit back in 1984. And even more incredibly, Arunima Sinha, who had actually lost a leg in a terrible train accident, she conquered Everest with a prosthetic leg in 2013. No way, right? It just goes to show that the human spirit is sometimes stronger than the highest peak on Earth.
Section 4, Sacred Summits, Mountains in Culture. Let's move from physical survival to our deep spiritual connection with these peaks.
Throughout human history, mountains have been way more than just rocks. They've been holy sites. This beautiful verse was written over 1,500 years ago by the revered ancient poet Kalidasa in his epic poem, the Kumara Sambhava. In the north rises Himalaya, the lord of mountains, like a living god who measures the earth. It perfectly, just perfectly captures the profound, almost divine awe that these massive physical structures inspire in all of us. They really do feel like they bridge the gap between earth and sky.
And because of that feeling, the sheer scale of a mountain, like Everest, inspires different cultures to name it and worship it as a divine entity. Tibetans call it Chomolungma, which means the mother goddess of the world. Nepalese call it Sagramata, the goddess of the sky. It's definitive proof that mountains are central cultural and religious landmarks, just as much as they are geological ones.
All right, Section 5, the roof of the world, an introduction to plateaus. As we wrap up this explainer today, let's descend just a bit to tease our next major landform. We've conquered the mountains, but what happens when a massive upland is just completely flat? Welcome to the plateau. Basically, a plateau is a landform that rises high above the surrounding landscape, but instead of having a narrow, sharp summit like a mountain, it's got this massive, more or less flat surface on top, usually bordered by steep sides. Think of it like a giant, elevated table made out of earth.
And these things can be absolutely gigantic. The vast Tibetan Plateau sits at a staggering average altitude of 4,500 meters. 4,500. It's the largest and highest plateau in the entire world. To put that sheer size into perspective, from east to west, it's nearly 2,500 kilometers long. That is roughly the entire distance from Chandigarh in the north of India all the way down to Kanyakumari at the southern tip. All of that landmass just raised thousands of meters up into the sky. Which leaves us with a really fascinating question to explore next time. How do delicate ecosystems and complex human societies possibly survive, let alone thrive, way up on the flat, freezing, windswept roof of the world? I mean, if mountains are hard to live on because of their steep slopes, what kind of unique challenges does a high-altitude flatland throw at you? Have a think about that. I'll see you next time as we continue our journey across the Earth's incredible landforms.